Finally, the barriers have been removed to locally produce high-quality AI video generations from your own images with low VRam. This has been made possible by the latest AI video generation made by Alibaba, which so far produced some of the best results locally free and starting with just 8 GB of VRam. The model is called WAN 2.1, used for both text to video and image to video. I'll be going through the image to video workflow, as this gives you far more control over your outputs. In these examples, you can see how these video generators have been trained on a huge range of dynamic videos, which has led to great accuracy and realism. For this workflow, I recommend taking a look at the ComfyUI wiki for reference. Actually, this is a great resource for your general ComfyUI workflows. Here I'll be following the WAN 2.1, but I'll make a few amendments to improve it. There are quite a lot of variations in the models that you can download and use, but mainly it all comes down to the resolution, quality, and what computing power you have available. Here you can see that there are two versions, a 14B and a 1.3B, which are 14 billion parameter and a 1.3 billion parameter versions. There are two models, one converting text to video, T to V, and image to video, I to V. And you can see it can run on just 8 GB VRAM, although the more you have, the better, as the low VRAM options are still very time consuming to run. Now on to downloading the required models. First step is the main diffusion model. You might be confused at first by this huge range of options, but each version is coded according to what I explained just now and depends on the quality of your VRAM. So I to V is for image to video, E to V is for text to video, and the resolution output you have options are 480p or 720p, which affect the generation time. Then there's the 14B and 1.3B parameter count. And then finally, we have the precision levels. So there's BF16, FP16, and FP8. So higher precision requires better hardware performance, with FP8 being the lowest precision and least demanding. Or download the I to V, 14B parameter, FP8, and the 480 resolution version. These can be downloaded and pasted into your ComfyUI directory under Models and Diffusion Models. At this point, I'll also mention there is an alternative to downloading these diffusion models. You can use the GGUF quantized models. In a nutshell, this is a mathematical process of quantization, which compresses the model for easier use on systems with limited RAM or VRAM. So I will show you both methods later on, but I do actually recommend using these quantized models. Again, if you go to the Hugging Face page here, or the links below, there's another long list. It just has the additional coding of going from Q3 up to Q8 versions. So these go from smaller and faster, low quality versions up to much larger, but running slower or high VRAM. So this completely depends on what machine you have and what balance you choose. But for example, for my 12 GB VRAM laptop, I'll be using this Q4 O version, which is in the middle for quality and speed. You can also see there are versions for the 480 resolution and for the 720. So I'll use the 480 as you'll speed things up, and these can be downloaded and pasted into your models and on the unit. The rest of the steps are straightforward. You could just follow these and download the models. So next is text encoders, and this goes into models text encoders folder. Then the clip vision file, which goes into your clip vision folder. And finally, the VAE model, which you may guess goes into VAE folder. There's only one option for each, so you can't go wrong. So to summarize, you need at least 4 files downloaded for this to work. With this, we can head over to ComfyUI. The first thing you need to do there is actually update ComfyUI from over in the manager, as you need all the latest installs. To start off, you can download this example workflow from ComfyUI wiki and drag and drop the JSON into your canvas. Starting with the diffusion model, you can select the one downloaded at the very start, but as I mentioned, I recommend instead to use the GGUF loader or the quantized faster versions. As you may remember, I chose to download the 480p Q4 version, so I'll load that and plug it in instead. You can of course move to higher res versions or higher quantized versions as you progress. Next is the text encoder, which you need to load the UMT5, the clip vision with the clip vision H model, and then in the BAE loader, you'll have the 2.1 BAE. For my input image, I will pick a square one to start with. For the standard 16:9 ratio videos, 640 by 480 pixels work well for the 480p version, and 1280 by 720 pixels work well for the 720 pixel version. Solutions work is by the total pixel count they're trained on, so the closer they are to that number, the better the results. I have tried 640 by 640 and still gotten good results on the 480p, but you can experiment around. For the length, this refers to how many frames or seconds your clip will be. I've selected 65 for a 4-second clip. And if your image is not the right size or aspect ratio, you can use the image resize node and connect that. Next, I'll add a descriptive input, paying attention to the movement and where I want the camera to go. And you can always add in more negatives if you want. For steps, it's recommended between 20 and 30, affecting quality and render time. And the CFG affects creativity. And the higher, the more precise it is to follow the inputs. For the sampler, I'll use the UniPC, as it is the fastest and the most decent quality. For slower and higher quality one, you can try the Euler A. And the rest can be left as default. Here I'll also delete these output nodes and add a video combine, so we can save to the MP4 format and set a frame rate of 16 for the initial generation. In the following steps, I'll show you how to increase the quality. Now you just have to generate and wait. This took over an hour on my laptop GPU of 12 VRam. And you can see the video consistency is still pretty good. Both the context and building do not deform as we zoom out. However, you can see it is a bit choppy due to the low frame rate. Increase this, you can add the RIFE frame interpolation node and an upscale image node. These need to be combined with a load upscale model. I recommend to download the 4x Full Hardy model, which can be taken from the Hugging Face site, and added to your upscaler model folder. These can be added directly to your VAE decode image before the video is combined, so you can chain them together. So once the video is generated, it can straight away have the frames interpolated and then upscaled to one video. However, if you already generate the video, or you want to do separate tests first to speed it up, you can separate these into different workflows, which I will do. So I'll delete these for now and move down the canvas. I will add these 3 nodes again. This time I will insert a load video and select the video we just generated. I'll connect this to the RIFE. And for the video combine at the end, we can increase the frame rate to 24. Set the multiplier to 2, double the frame interpolation for smoother action. And then finally connect these all together. I will just select all the previous nodes and click bypass so that the top part doesn't run again. And now it will generate. This upscaling just took a fraction of the time compared to the original video generation, so definitely worth adding, and you can see how much smoother the video is. In addition, if I move it over to the folder, you can see this video is now 2560 resolution in comparison with the 640 part. So a huge difference. The video generation, as you can see, has taken a massive step forward with this new model, And even though it takes a long time to generate on a low VRAM machine, video generation is an intensive process, so it is amazing that it's even possible to create such realistic videos locally. And of course, you step up your GPU and have one such as the RTX 4090, you can use higher GGUF models and produce much better results, and much quicker, all for free. Be sure to try these out and look forward to see what you can produce.